Hello and welcome to this revision session for AQA A-Level Physics Paper 1 on the topic of circular motion. So if we're successful and we learn in today's revision session, we should be able to answer examination questions on A-Level Physics Paper 1 on the topics of circular motion. So if we've been successful and we've learned in today's lesson, we should be able to answer A-Level Physics examination style questions for circular motion, assess our understanding on circular motion for A-Level Physics, and understand what topics we need to improve upon for AQA A-Level Physics in the circular motion topic. So how should you prepare for this revision session? Well, when you're completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side. In this left hand side section, write down your working out and answers to the question in the revision session. When you're doing this, make sure to write in full sentences and show the full working out. Whilst on the right hand side, write down any bits of information which you find useful or any hints and tips on answering questions from this revision session. After the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising for A-Level Physics? So the first step is to learn the key facts. Use revision guides, class workbooks, student prep notes, the textbooks to learn the key ideas of the course. You may wish to make mind maps or write out the notes yourself. The second step is retrieval, testing yourself, using the Caboodle e-learning platform, using the Seneca e-learning platform, using student knowledge checkers to quickly test your own knowledge, and you may wish to do this from your own cue cards. And then finally, practice examination style questions. Use exam prep books, homework books, supervised study books, additional workbooks to answer questions and mark your own work, and you may wish to download your own examination past papers to do this. So you should have the three steps of learn the key facts, testing yourself, and practicing exam style questions. So in this revision session, you'll see three types of question. Firstly, there'll be general check questions, basic questions designed to probe your understanding of the key concepts of the topic. You've got the checkpoint questions, which are the more challenging questions designed to place your knowledge and understand the topics into different contexts and application. And then finally, you've got assessment points, the past paper exam questions which mimic the type of questions found in public examinations. So let's now have a look at the topic of circular motion. The first question says, explain what is meant by a radian. And the second question says, a body moves around in a circle at a constant speed and completes one revolution in 15 seconds. Calculate the angular velocity of the body. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, it's all about you've got to understand the definition of what the radian is. So by definition, the radian is the angle subtended at the centre of a circle by an arc equal to the length of the radius of the circle. Now the second question, again, is a test of how you work at angular velocity. Angular velocity is 2 pi over t, because 2 pi is the completed displacement in one revolution and t is the time of one revolution. So 2 pi over 15 is 0.42 radians per second, because remember, it's going to be an angular displacement of 2 pi radians in one whole circle. Next question, express the following angles in radians: 180 degrees, 45 degrees. Then calculate the angular velocity of a roundabout which completes one revolution in 30 seconds, and then a spinning top with a time period of 0.10 seconds. So pause the video now, then unpause the video when you want to go through your answer. Right, in this you've got to be aware of how you can convert angles from degrees into radians, and you could either do it one of two ways. You could remember that there are 2 pi radians in 360 degrees, or you could do the angle in degrees divided by 180 over pi, so therefore it would work to be pi radians, which is 3.14 radians. Again, 45 degrees by those logics will equal a quarter pi radians, or 0.79 radians. Again, angular velocity is going to be 2 pi over t. Now again, it tells you that the time for one revolution is 30 seconds, so it's going to be 2 pi over 30, 0.21 radians per second. And this next one, 2 pi over 0.10 seconds, 63 radians per second. The next question says, name the actual force that provides the centripetal force in the following examples and state the direction of the force. A satellite in orbit of the Earth, an electron going around a nucleus, a cyclist going around the bend. Then calculate the linear speed of a particle just 20 centimeters from the center of a disk spinning at 6 radians per second. Then calculate the centripetal acceleration of the following objects. A car moving around a bend of radius 60 meters at a speed of 20 meters per second. A yo-yo swung in a circle with a radius of 30 centimeters at 5 radians per second, and an object moving in a circle of radius 1.5 meters with a period of 750 milliseconds. So pause the video now, then unpause the video and you'll want to go through your answer. Right, in this first one, remember the centripetal force is the name given to the resultant force towards the centre of the circle of the circular motion. So the first one is going to be gravitational attraction towards the centre of the circular motion. The second one is going to be electrostatic attraction towards the centre of the circular motion. Then a cycle's going on the bend, that's the friction between the tyre and the road, towards the centre of the circular motion. Again, how can you link a linear speed to the angular velocity? Well, it is v equals r omega, so therefore you can say it's going to be 0.20 because we convert centimetres into metres times by 6 radians per second, so it's 1.2 metres per second. The next one, how can you work out centripetal acceleration? Well, centripetal acceleration equals v squared over r. So you can convert your values in and you get 6.7 meters per second squared. The next one, you can also use the equation A equals omega squared r. Again, it just depends on what values you give it in the question. So it's going to be 5 squared times by 0.60 because it's 60 centimeters into meters, so it's 15 meters per second squared. Now in this next one, you're given the time period. So when you're given the time period, you can then work out the angular velocity by saying omega equals 2 pi over t. We convert our milliseconds into seconds, so you get 8.4 radians per second. We then say A equals omega squared r to get out 110 meters per second squared. The next question says, a bicycle wheel rotates at 120 revolutions per minute. The radius of the bicycle wheel is 280 millimeters. Firstly, calculate the angular velocity of the bicycle wheel. Secondly, calculate the centripetal acceleration of the bicycle wheel. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, you need to work out the angular velocity, and you can do so by converting your revolutions per minute into revolutions per second, and then you can then work it out by then using this idea of doing 2 pi over 60. So you can go 120 there, say, so times by 2 pi in general, sorry, so it'll be 2 pi, okay, over 60 times by 120 is therefore going to equal 4 pi radians, so you get a 12.57 radians per second. We can then use the equation A equals omega squared r to pop in the values. Remember the radius converts from millimeters into meters, so we get 44.216 meters per second squared. The next question says, the figure shows part of a track of a roller coaster ride in which a truck loops the loop. When the truck is at a position shown, there is no reaction force between the wheels of the truck and the track. The diameter of the loop in the track is 8.0 meters. Explain what provides the centripetal force to keep the truck moving in a circle. Then, given that the acceleration due to gravity, g, is 9.8 meters per second squared, calculate the speed of the truck. So pause the video now, then unpause the video when you want to go through your answer. Right, remember that the centripetal force is always the resultant force towards the centre of the circle. So when the truck is in the position as shown, the centripetal force, okay, must be acting downwards towards the centre of the circle. So the only downward force in this instance, because there's no reaction force, is going to be the weight of the truck. So therefore, how can we work out the value for the speed of the truck? Well, what we can say is, we can say that acceleration is equal to v squared over r, and we know the acceleration is going to be g, 9.8 meters per second squared, because the only thing accelerating it is gravity. So therefore we can rearrange it. We can make v the subject and say v squared equals rg. So therefore v equals the square root of rg, and it equals 6.3 meters per second. The next question says, a racing car of mass 1,200 kilograms travels around a bend with a radius of 140 meters. The maximum frictional force between the wheels and the track is 17 kilonewtons. Calculate the maximum speed at which the car can travel around the bend. So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to remember that we're working out the centripetal force here. Because we know the mass of the car, we know the radius, and we know that the general equation for this is going to be F equals mv squared over r. Now we know what F is, it's 17 kilonewtons, so we convert that into newtons. We know m, which is 1,200, and we know the radius, which is 140. So we pop them all into the equation, we work it through, and we get 45 meters per second. We can use the equation F equals mv squared over r because it's going in a circular motion, and that must be the resultant force towards the centre of that circular motion. The next question says, On a ride of a theme park, riders are strapped into seats attached to the edge of a horizontal wheel of diameter 8.5 meters. The wheel rotates 15 times per minute. Calculate the force felt by the rider of mass 60.0 kilograms. Then, a car is being driven in a circle of radius 56.8 meters with a linear speed of 31.1 meters per second. Calculate the centripetal acceleration of the car. Then, the linear speed of the car decreases to half of its original value. If the original centripetal force experienced by the car was F, what is the new centripetal force experienced by the car in terms of F? Then, a biker rides in a vertical circle around the inside of a cylinder of radius 5.0 meters, so he's upside down at the top of the cylinder. For the biker not to fall off at the top of the loop, he must be going fast enough that his centripetal acceleration does not drop below the acceleration due to gravity. What is the minimum speed they must be travelling at the top of the loop? So pause the video now, then unpause the video and you want to go through your answer. Right, in this first one, you've got to remember, what can you work out? Well, you can work out the frequencies. You can say it's 15 over 60 to work out that there's going to be 0.25 revolutions every second. You can then work out your angular speed. Now remember, angular speed or angular velocity, omega, is equal to 2 pi f. That's an equation you've got to be able to use. It is given to you in your exam. So now we've got f, we can work out the angular speed. So we've got 0.5 pi radians per second. At this point, we can use the centripetal force equation to work out the final force, because it's moving in a circular path. Now we can't use the equation F equals mv squared over r because we don't have v, but we do have omega. So we can use the other form of the equation where we say F equals m omega squared r, pop in all the values. Now remember, you're given the diameter in the question, not the radius, so you've got to half it, so therefore you get 630 newtons. This next question, we can use the equation centripetal acceleration is v squared over r, because we've got v and we've got r, so you pop in the values and we get 17.0 meters per second squared. Now, we'll see how the centripetal force changes in the next question. We know F equals mv squared over r. So therefore, if m and r are kept constant and v is halved, well, it's v squared. So therefore, the value of the centripetal force is quartered, so it's F over 4. Then finally, if the biker's speed is the minimum possible from not to fall, then therefore our centripetal acceleration towards the top of the cylinder, towards the centre from the top, will be 9.81 meters per second squared. We know A equals v squared over r, so therefore we can work out what v is. So v would be the square root of a times by r, so be square root of 9.81 times by 5, so it's about 7 meters per second. Let's now have a look at a few more contextual questions. So the first question says, for how many degrees does the angular displacement of the hour hand of a clock change each hour? Then a clock is shown 3.30 or half past 3. Calculate the angular displacements in degrees from 12, the 12 position of the clock, to the minute hand and then the hour hand. And then convert the following angles from degrees to radians. 30 degrees, 90 degrees, 105 degrees. Convert these angles from radians to degrees. Half a degree, half a radian, 3/4 of a radian, pi radians, and pi over 2 radians. Then express the following angles as multiples of pi radians: 30 degrees, 120 degrees, 270 degrees, 720 degrees. So pause the video now, then unpause the video and you want to go through your answer. Right, in this first one, you know that the full circular face of a clock will be 360 degrees. We know a clock face is divided into 12 sections because it goes from 12 all the way back round again. So therefore it's 12 sections. So the angular displacement of the hour hand per hour is going to be 360 degrees divided by 12, which is 30 degrees. Now this next one, you would say the angular displacement of the minute hand is going to be half of the clock face, because as it goes from 12 to that particular, from 3:30 to 12, so we half the clock face, so it's 180 degrees. And for the hour hand, it's actually going to be 30 degrees, because it's going to be moving across like that, but it's going to be 3.5 hours of the 30 degrees, so therefore it's 105 degrees, because each hour gives you a 30 degree angular displacement or change, so therefore it's 3.5 hours, which is the difference, so it's 105 degrees. Again, to change from degrees into radians, you times your angle in degrees by pi over 180. So you're going to get 0.52 radians, 1.57 radians, 1.83 radians. To convert from radians to degrees, we will times by 180 over pi, or you could say divide by pi over 180. So you get 20 28.6 degrees, 43.0 degrees, and 180 degrees. Now, if you think about in terms of multiples of pi radians, well, 30 degrees is going to be 30 times by pi over 180, so it's pi over 6 radians. The next one, 2 pi over 3. Next one, 3 pi over 2. Then the last one, 4 pi radians. The next question says, calculate the angular velocity of the Earth as it moves around the Sun. Then a hard disk spins at 4,500 revolutions per minute. Calculate the angular velocity and the time it takes to complete 50 revolutions. Then a spinning disk has an angular velocity of 565 radians per second. Calculate the frequency of rotation and the time taken to complete 5,400 revolutions. So pause the video now, then unpause the video and you want to go through your answer. Right, in this first one, you've got to think about what the time will be for the time to go for the Earth to go around the Sun. And you've got to be in seconds. You do 365 times by 24 times by 60 times by 60. We then say angular velocity is 2 pi over t, as we looked at before. So it's 2 times by 10 to the minus 7 radians per second. Now the next question, we've got to convert our revolutions per minute into revolutions per second. So you divide it by 60 to get 75 revolutions per second. We then say pi equals, we say that omega equals 2 pi f. So therefore it's 2 pi times by that 75 is 470 radians per second. So to complete 50 revolutions, what you'll do is you'll do 50 times by the time period, which is 1 over the frequency. So it's 50 times by 1 over 75, 0.67 seconds. We can use the same methodology in this next question, but we can say f equals 2 pi over omega, because omega equals 2 pi f. So therefore we can say f equals 565 over 2 pi is 90 hertz. Then the time taken is 5,400 times by the time period, which is 1 over the frequency, so it's times by 1 over 90, which is 60 seconds. The next question says, explain why all the velocity arrows in the figure are drawn at the same length. Then, a toy train travels at a steady speed of 0.2 meters per second around a circular track. A and B are 2 points diametrically opposite to one another on the track. Determine the change in speed of the train as it travels from A to B, and then determine the change in the velocity of the train as it travels from A to B. Then, show the angular velocity of the second hand of a clock is about 0.105 radians per second. Then, the drum of a washing machine spins at a rate of 1,200 revolutions per minute. Determine the number of revolutions per second of the drum and determine the angular velocity of the drum. So pause the video now, then unpause the video and you want to go through your answer. Right, so in this first one, the magnet, they're all the same length because on the vector diagram, the length of the arrow shows you the magnitude of the vector. So the magnitude of the vector is remaining the same because the speed in circular motion stays constant. It's the direction that will change. Now in the next question, we know that the speed is a scalar and it's a constant value. So the change in speed from A to B, okay, is going to be 0 because you don't need to consider the direction. But in the second one, we do need to consider the direction. So because the object is changing directions, one of them has to be a negative value. So therefore it can be 0.2 minus 0.2, which is therefore adding it. So it's 0.4 meters per second for your change in velocity. Now this next question, we have looked at this before, but the second hand on a clock turns 360 degrees in 1 hour, so therefore, in 1 minute, sorry. So therefore it's 2 pi radians in 1 minute. So therefore it's 2 pi over 60 radians in 1 second. So therefore the angular velocity is going to be 2 pi divided by 60. So therefore it's 0.05 radians per second. In this next question, the revolutions per minute is 1,200. So you divide it by 60 to get in revolutions per second, which is 20. So our angular velocity, we know angular velocity is going to be omega, okay, which is 2 pi f. We know the frequency from before is the revolutions per second, so it's 20. So it's 2 pi times by 20, so it's 40 pi radians or 130 radians per second. The next question says, okay, that the angular velocity of the second hand of a clock is 0.05 radians per second. If the length of the hand is 1.8 centimeters, calculate the speed of the tip of the hand as it moves around. Then a car travels a 90-degree bend in 15 seconds. The radius of the bend is 50 meters. Determine the angular velocity of the car. Determine the speed of the car. Then a spacecraft orbits the Earth in a circular path of radius 7,000 kilometers from the center of the Earth at a speed of 7,800 meters per second. Determine its angular velocity. So pause the video now, then unpause the video and you want to go through your answer. Right, in this first one, we've got to remember V equals omega R. So therefore it's going to be 0.05 times by 1.8, and it's 0.19 centimeters per second. If you want to convert it to meters per second, convert the centimeters into meters. The next question says determine the angular velocity. Well, we know that the angular velocity is the change in angle over the change in time. Now it's not a full revolution here, so we can say it's going to be 90 times by pi over 180. So we know that's going to be it's going to be pi over 2 radians, and then we're going to divide that then by 15 seconds, so it gets 0.05 radians per second. Then the speed is equal to omega r, so we multiply that by the radius, which is 50 meters, to get 5.2 meters per second. Now again, we can use this equation in the next one, and we can use this to work out angular velocity, because you know angular velocity therefore must be v over r. We convert the kilometers into meters, and therefore we get our answer to be 1.1 times 10 to the minus 3 radians per second. The next question says an object moves in a circular path of radius 30 centimeters with a velocity of 1.40 meters per second. Calculate the angular velocity and the centripetal acceleration of the object. Then a roller coaster designer creates a loop where the acceleration at the bottom of the loop is 5 times greater than the acceleration of free fall. The radius of the loop is 12 meters. Calculate the speed of the roller coaster required to provide such an acceleration. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, we know we can work out the angular velocity because we've got the linear velocity and we've got the radius of the circular motion. We've got to convert the centimeters into meters, so we get 4.7 radians per second. We can then work out our acceleration by doing v squared over r, so it's then going to be 1.40 squared over 0.30, 6.5 meters per second squared. In this next question, we can work out what the acceleration of our object must be. It must be 5 times greater than the acceleration due to gravity, so therefore you can work it out to be 49.1 meters per second squared. We know a equals v squared over r, so v equals the square root of ar. Pop in all the values and you get 24 meters per second. The next question says, show that in one revolution there are 2 pi radians. Then the figure below shows a centrifuge used to separate solid particles suspended in a liquid of lower density. The container is spun at a rate of 450 revolutions per minute. Calculate the angular velocity of the container. Then calculate the centripetal force on a particle of mass 20 milligrams at the end of the test tube. An alternate method of separating the particles from the liquid is to allow them to settle to the bottom of the stationary container under gravity. By comparing the forces involved, explain why a centrifuge is a more effective method of separating the mixture. So pause the video now and unpause the video when you want to go through your answers. So how do you answer this question? Well, the first one is you've got to think about what the situation is when you're doing one complete revolution. So that the angle in radians, like we said before, is the length of the arc divided by the radius. But the length of the arc must actually be the situation that's taken place. So therefore the length of the arc must be the entire circumference in this case, because it's one complete circle. So that's 2 pi r. So therefore we can say 2 pi r over r equals 2 pi. So the angle in radians of an entire revolution is 2 pi. Now in this next question, the angular velocity, we can say when we work it through is omega equals 2 pi f. That's an equation you've got to remember. So therefore you can work it through and you can pop in all the values. Remember to convert revolutions per minute into revolutions per second, which is the frequency, by dividing by 60. So we multiply that by 2 pi and we get 56.5 radians per second. Now in this next question, f is equal to mr omega squared. We use that equation because we just worked out omega and we have r and we have m. Now note it's 20 milligrams. Now it's 20 times 10 to the minus 6 because the standard unit in physics is the kilograms. So to go from milligrams back into the standard unit, you've got to do 10 to the minus 6, not 10 to the minus 3. Pop in all the values and you get 6.4 times 10 to the minus 3 newtons. Now the next one, you can do this by looking at the value of the forces. So the weight of the object, which is the separation due to gravity, is going to be equal to 20 times 10 to the minus 6 there, times by 10, so therefore it's going to be 0.2 times 10 to the minus 3, which is much less than the required centripetal force. The next question says, in training, military pilots are given various tests. One test put them in a seat on the end of a large arm which is spun around at high speed. Describe what the pilot will feel and relate this to the centripetal force. At top speed, the pilot will experience a centripetal force equivalent to 6 times his own weight. Calculate the speed of the pilot in this test, then calculate the number of revolutions of the pilot per minute, and then finally suggest why it is necessary for pilots to be able to withstand forces of this type. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you do this one? Well, the first one, you say the pilot would feel thrown out from the circle or pressured outwards against the seat, because the inertia means that there'd be no force. Okay, if there's no force in the situation, the pilot would want to travel in a straight line, but there's a centripetal force acting to pull them towards the center of the circle. So in the vertical plane, they'd have inertia, but in the horizontal plane, they'd be pressed in towards the center of the circle. So ultimately, that will cause a reaction to make the pilot feel pressured outwards against the seat. Now, to work out the speed of the pilot in the test, we can say, well, mv squared over r equals 6mg, because that is the centripetal force, and that's the equation for the centripetal force. So we can rearrange that and say v squared equals 6 times by rg. So we pop in all those values. Remember, g is 9.81, so we get 294. Then we square root that to get 17.2 meters per second. Now, the number of revolutions of the pilot per minute, well, we do omega equals v over r. We can therefore work it through to therefore equal 0.54 revolutions per second. Then to get into the minute, we can times it then by 60 if we would want. Now, the next question, why are they going to be able to stand forces of this type? Well, the sharp turns in combat mean at high speed would mean they'll experience very high g-forces when they're moving around like that, so they've got to be able to withstand them. The next question says, a car is travelling around a bend when it hits a patch of oil. The car slides off the road onto a grass verge. Explain, using your understanding of circular motion, why the car came off the road. So pause the video now, then unpause the video when you want to go through your answer. Right, so what's happening is we know that the centripetal force in this case is the resultant force towards the centre of the circle. So that is the friction between the tyres and the road. Now therefore, if you've got oil on the road, you're going to reduce this value of frictional force. So therefore, the frictional force is not enough to push the car around in the desired curve. So therefore, it has to be in a wider arc because the value of F is lower. So therefore, it's going to hit the grass verge. The next question says, on one end of a string, it's secured to a ceiling and a metal ball of mass 50 grams is tied to the other end. The ball is initially at rest in the vertical position. The ball is raised to a vertical height of 70 centimeters. The ball is then released and it describes a circular arc as it passes through the vertical position. The length of the string is 1.50 meters. Ignoring the effects of air resistance, determine the speed of the ball as it passes through the vertical position. Then calculate the tension in the string when the string is vertical. Then explain why the answer to this is not equal to the weight of the ball. So pause the video now, then unpause the video when you want to go through your answer. Right, you've got to remember in terms of energies that, because we're not thinking of air resistance, we can say that the change in potential energy is going to equal the change in kinetic. Now I think I'm going to use this equation because I have values of G and of H and we want to work out V. So that's a really nice equation we can use because we can say, well, V equals the square root of 2GH when we cancel everything through. So you pop in all the values, we get 3.712 meters per second. Now we're trying to work out the tension in the string. Now you've got to think to yourself, well, what's the situation going on in this scenario? Well, we know the centripetal force, the resultant force towards the center of the swing, is going to be equal to mv squared over r. So you can work it through with all the information you've been given. You just worked out v in the previous question to get 0.548 newtons. Now, what's the resultant force towards the center? Well, it's the tension, okay, which is going towards, which is going to be going towards there minus mg because it's going away from the center. So therefore, T minus mg equals the centripetal force, which we've just worked out. So therefore T equals the centripetal force plus mg, the weight. So therefore it's 0.95 newtons. Now why is this not equal to the weight of the ball? Because the weight is only equal to the tension when it's at rest in the vertical position, because at that point the only resultant force towards the center of the circle, the centripetal force, is going to be the weight. So the ball isn't in equilibrium in the vertical position because it's got an upward centripetal acceleration. The next question says, figure 17.20 shows an aeroplane banking to make a horizontal turn. The aeroplane is travelling at a speed of 75 meters per second and the radius of the turn in a circle is 80 meters. On the diagram, draw and label the forces acting on the aeroplane. Then calculate the angle which the aeroplane makes with the horizontal. So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to think about what's the forces acting on this aeroplane as it's going in a circular motion. Well, we'll always have weight acting vertically downwards from the centre of mass, and you've got the lift force, which is going to be acting against the weight, but it'll be perpendicular to the wings, because it's the wings that are helping produce the lift force, and those are the two forces acting on the aeroplane. Remember, the centripetal force is not an actual force, it's just the resultant composite acting towards the centre of the circle, so it doesn't have its own particular force arrow in this diagram. Now the next one, what we've got to do is, because it's at an angle, we've got to resolve the lift force horizontally and vertically. Because the lift force is at an angle, okay, we can't have it purely in the horizontal or purely in the vertical. So we know that vertically it's going to be L sine theta, and then its resultant force vertically will be the weight, so it'll be L sine theta equals mg. We can then say horizontally that the resultant force towards the centre is the centripetal force, but the component of the lift force is going to be L cos theta, so L cos theta equals mv squared over r. Now we don't have the value of L in this equation, so we've got to cancel it through. So we can do the vertical equation divided by the horizontal equation. The L's will cancel through, and sine over cos becomes tan theta, a mathematical trigonometric identity you learn in GCSE maths. So therefore tan theta is going to equal 80 times by 9.8, which is going to be the radius times by the acceleration due to gravity, g. Then we divide it by the speed squared, so therefore we get 0.39. We inverse tan that to get 7.9 degrees. The next question says, explain what is meant by the term angular velocity. And then figure below shows a rubber bung of mass 200 grams on the end of a length of string being swung in a horizontal circle of radius 40 centimeters. The string makes an angle of 56 degrees with the vertical. Calculate the tension in the string, the angular velocity of the bung, and the time it takes to make one complete revolution. So pause the video now, then unpause the video when you want to go through your answer. Right, what do we know about this? So what is the angular velocity? Well, it's the angle covered or the displaced angle per unit time, but the angle has to be given in radians. Now, what's the tension? Well, if you notice here, we can see that vertically the tension, okay, is going to have, okay, a vertical component, and in this case, it's going to be T cos theta, and that's going to equal the resultant vertical force, which is the weight of the object, because that's the only other force acting upon it. So therefore, T cos theta equals mg. They equal each other because they're in equilibrium, because they're traveling at a constant velocity, so a constant speed. Okay, so therefore T equals 0.200 times 0.981 cos 56, which is 3.5 newtons. We know that horizontally, the resultant horizontal force, the resultant force towards the centre of the circle, is the centripetal force. That equals mv squared over r. So therefore T sine theta, which is 3.5 sine 56, is going to equal mv squared over r, or m omega squared r. So therefore we can work out omega. By looking it through, we can say it is 6 radians per second. So therefore, the time period is going to be 2 pi over the angular velocity, because angular velocity is 2 pi over t. So therefore, it's 2 pi over 1.04, which is therefore 1 second. The next question says, explain what is meant by the centripetal force. Then a teacher swings a bucket of water of mass 5.4 kilograms round in a vertical circle of diameter 1.8 meters. Calculate the minimum speed which the bucket must be swung at so the water remains in the bucket at the top of the circle. Then assuming the speed remains constant, what will the force on the teacher's hand be when the bucket is at the bottom of the circle? So pause the video now, then unpause the video when you want to go through your answer. As I said before, the centripetal force is the resultant force acting towards the centre of a circle on a body moving around that circle. It's a category we place forces into, it is not a force itself. This next one, we know that in this situation, when it's at the top of the circle, the resultant force towards the centre of the circle is the resultant force vertically downwards at that point. So therefore the centripetal force is equal to the weight. So we can say mv squared over r equals mg, the m's cancel through, v squared equals rg, so therefore v equals 3 meters per second. Then this next one, what will the force be? Well, the force is going to be equal to 2 mg, because at this point it's at the bottom of the circle. So not only do you have the tension acting downwards, but also you've got the force acting downwards. So therefore, it's going to be double the weight. So it's 2 times by 5.4 times by 9.81, 106 newtons. The next question says, a model aeroplane moves in a horizontal circle. The path of the model aeroplane is a radius of r. The dots on the diagram represent 2 positions of the model aeroplane as it moves with a constant speed v. Derive the equation for the centripetal acceleration a equals v squared over r by considering the velocity of the model aeroplane at these 2 positions. Your answer should include a vector diagram. Then a model aeroplane is then attached to the wire. The wire is held by a person. The aeroplane moves in a horizontal circle of radius 28.5 meters at a speed of 22.5 meters per second. A lift force acts vertically upwards on the aeroplane. The lift force is equal to twice the weight of the aeroplane. The mass of the aeroplane is 1.55 kilograms. The wire will break if the tension is greater than 35 newtons. Deduce whether the wire will break. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, we've got to use the idea of the vector diagrams. So if you see this vector diagram here, we can look at that. We can make a triangle from the center to A and then the center to B, and then we can use that to work out values. So we can say that VA equals VB equals V, so it's a constant magnitude for that particular velocity. So therefore, with the small angle approximation, we can say the change in angle, the change in theta, is equal to change in V over V. Now we know that V is equal to omega t when we've worked it through. We can link it into omega, because we can say the angular velocity omega is equal to the change in angle over the change in time. So therefore the change in angle is equal to omega times by the change in time. So therefore the change in angle is equal to V change in time over r. So we've subbed in omega equals V over r. We can then rearrange it, and therefore we can link it through, as you can see on the screen. We can then cancel it through. Now remember, the change in velocity over the change in time is going to be acceleration. That's the definition of acceleration. So it's V squared over r. In this next question, we can say that the centripetal force equals mv squared over r. So it's 1.55 times by 22.5 squared over 28.5, so equals 27.5 newtons. Now we know the weight is going to be mg, so it's 15.2 newtons. So therefore the overall resultant is, when we use Pythagoras' theory, because we want to work out the resultant, which is going to be the tension. So it's going to be the square root of the centripetal force, okay, squared plus the weight squared. So for you work it through, it's 31.4 newtons, which is less than 35. You give your conclusion to your answer, so the wire will not break. The next question says, an aeroplane flies in a horizontal circular path while waiting to land at an airport. The aeroplane flies in a horizontal circle by tilt to one side in a movement called banking. The aeroplane creates an upwards lift force which acts in a direction perpendicular to its wings. The diagram shows this lift force when the aeroplane is banking. Explain how banking allows the aeroplane to fly with a horizontal circular path. Then during banking, the angle between the wings and the horizontal is 5.2 degrees. Calculate the radius of the circular path when the aeroplane flies at a constant speed of 530 meters per second. The mass of the aeroplane is 4.1 times 10 to the 5 kilograms. So pause the video now, then unpause the video when you want to go through your answer. Right, what you got to remember is the vertical component of lift will equal the weight of the aeroplane, because it's overall in equilibrium. So the two vertical forces will balance. So the vertical component of the resultant force is 0, because the aeroplane isn't accelerating vertically. It's not accelerating up or down vertically. So therefore it therefore means it'll remain flying horizontally. Now we know the horizontal component of the lift will act as a centripetal force. So the resultant force on the aeroplane is the horizontal. It's the only one that's left. So it acts as the centripetal force. So therefore, because you've got inertia in the vertical plane, you've got a resultant force towards the center of the circle in the horizontal plane, you will get circular motion. Now in this next question, we know that W is equal to mg, so 4.1 times by 10 to the 5 times by 9.81 equals 4.02 times 10 to the 6 newtons. That's the weight. Now we know that the vertical component of the lift is L cos theta, so therefore it is L cos 5.2, which is going to be 4.02 times 10 to the 6. So therefore what we can do is therefore we can then work out values, because we can then also say that therefore we can say L is going to therefore be equal to 4.04 times 10 to the 6, because we can say L cos 5.2 equals mg, or the weight, so we can work out L via that method. We can then say, well, we know mv squared over r is going to equal to L sine 5.2, because that's in the horizontal, so therefore we can work out that the value for the centripetal force is going to equal to be 3.66 times 10 to the 5 newtons. We can then say, well, r is a factor we don't know about, but we know the value for F, and we know F equals mv squared over r, so therefore r is equal, and we rearrange everything, to 3.15 times 10 to the 5 meters. The next question says, a car travelled in a circular path as shown. A passenger in the car made the following claim. When the car was travelling at a high speed around a circular path, I was thrown outwards towards a force due to a force acting on me. The outwards force acting on me was the centrifugal force. Assess the claim made by the passenger. So pause the video now, then unpause the video when you want to go through your answer. Right, in how to answer this one? Well, thinking about it, an application of Newton's first law to the path of the car passenger, so if there's no force on the car passenger, they'll continue in a straight line. So you need a force to change a resultant force to change the direction for the car or the passenger. So therefore a force was exerted on the car towards the centre of the circle. This inwards force was exerted on the car at right angles to motion, so even though they were going, as you say, vertically upwards, it was acting horizontally. So therefore that is the definition of a centripetal force as well. It is a force that acts perpendicular to the motion of the object. This inwards force was exerted by the car and the passenger, so therefore there's not actually an outward force on the passenger. That's actually a misnomer of the situation. So there's no such thing as a centrifugal force. There's only an inwards force towards the centre of the circle, which is the centripetal force. So the centrifugal force is what we call a fictitious force. The next question says, the photograph shows children on a roundabout in the playground. The roundabout is a flat platform with bars. The children makes the platform rotate by running on the ground whilst pushing on the bars. It takes 12 seconds for the roundabout to make 2 complete rotations. A child is standing on the platform 1.8 meters from the centre of the roundabout. Calculate the speed of the child. So pause the video now, then unpause the video when you want to go through your answer. Right, you're told enough information to work out the angular velocity, because we know angular velocity is 2 pi over t. So it's 2 pi over 6, because remember there's 12 seconds for 2 complete rotations, so 6 seconds for 1 complete rotation, so it's 1.05 radians per second. We know v equals omega r, so therefore it's 1.89 meters per second. The next question says, a poi ball is a ball attached to a person's hand by a cord. A child makes the poi ball undergo circular motion in a vertical plane as shown in the photograph. The poi ball moves clockwise in a circle of radius r with a constant speed v. The diagram shows 2 positions a and b of the poi ball. Firstly, derive the equation for the centripetal acceleration a equals v squared over r by considering the velocity of the poi ball at these 2 positions. Your answer should include a vector diagram. The poi ball completes 1.3 revolutions per second. Calculate the acceleration of the poi ball. The radius of the circular motion is 0.58 meters. Then the child comments that as the ball goes around the circle with a constant speed, the size of the force on his hand changes. Discuss whether this comment is correct. So pause the video now, then unpause the video when you want to go through your answer. Like previously, you got to make a triangle from 0 to A and 0 to B and A to B. So you should draw this triangle out. You can then use a small angle approximation to say the change in angle is equal to the change in V over V. Remember, the small angle approximation takes away sine, cos and tan. So at that point we can also say that, well, change in theta equals omega times by change in time, because omega equals change in theta over change in time. We can sub in that omega equals V over r, so we've got v and r in the equation. We then rearrange it, and we can then get delta, the change in velocity over the change in time as the subject. That is acceleration. So therefore acceleration equals v squared over r. In this next question we can say, right, well, v equals 2 pi f times by r. So we can say it's 2 pi times by 1.3 revolutions per second, because that is in fact the frequency, times it by the radius. You get 4.74 meters per second, and then a equals v squared over r. Pop in all the values, 38.7 meters per second. Now the child's claim is correct because the centripetal force is the force that he feels on his hand. Now we know that throughout this effect the tension is constant. Now the weight of the ball is added to the tension at the top because they're both acting towards the centre while they're at the top, but the weight is subtracted from the tension at the bottom because that's acting in the opposite direction to the centre of the circle at the bottom, so therefore the overall resultant force will vary, and the child is therefore correct because whilst the tension is constant, the resultant force is not. The next question says, if the Earth orbits the Sun in a circular path, and we've got 1 year is 3.2 times 10 to 7 seconds, the radius of orbit is 1.5 times 10 to 11 meters, and the mass of the Earth is 6 times 10 to 24 kilograms, calculate the angular velocity of the Earth, the linear speed of the Earth, and the centripetal force needed to keep the Earth in orbit around the Sun. So pause the video now, then unpause the video when you want to go through your answers. Right, in this first question we know omega equals 2 pi f, so therefore it's 2 pi over 3.2 times 10 to the 7, because remember it's 1 over the time period, so we get to 2.0 times 10 to the minus 7 radians per second. Linear speed is equal to omega r. We've just worked out omega, we multiply by r, and we get our answer out to be 29,000 meters per second. Then the next question, we're going to then look at the centripetal force, so F equals mv squared over r, the resultant centripetal force equation. You pop in all the values and you get 3.5 times 10 to 22 newtons. The next question says, a small object of mass 80 grams is attached to a string of length 1.2 meters swung in a vertical circle. It travels at a linear speed of 4.8 meters per second. Calculate the tension at the highest point and the tension at the lowest point. So pause the video now, then unpause the video when you want to go through your answers. Right, at the highest point, we know the following. We know that the resultant force towards the centre of the circle is the centripetal force, but it's also equal to the idea of T minus F. Okay, so we can say F is mv squared over r, so therefore we turn grams into kilograms by doing 10 to the minus 3. We then work it through and we get 1.536 newtons, but we know that the tension is equal to mg plus F, so therefore tension equals F minus mg, because F is the resultant force towards the centre of the circle, and mg, okay, is the weight of the object, and T is the tension. So when you do your diagram, it works through like that, so therefore it's going to be 0.75 newtons. Whilst at the lowest point, it's reversed. So actually now, whilst F is still the same because it's still mv squared over r, and this centripetal force due to that is 1.536, we know that F equals T minus mg, because at the lowest point we know that mg is acting in the opposite direction to the centre of the circle, so therefore it's a minus value, so therefore T equals F plus mg, so you add it, so therefore it's 2.3 newtons. The next question says, a light aircraft flying horizontally at 70 meters per second has a propeller of radius 0.5 meters, which makes 20 revolutions per second. Firstly, calculate the velocity of the tip of the propeller. Then when the propeller is at its highest point, calculate the force experienced by a 0.2 g mass attached to its tip, and then state what provides this force. So pause the video now, then unpause the video when you want to go through your answer. Right, so for this first one, we know omega equals 2 pi f, and we've got f because it's revolutions per second. So we say, well, it equals 40 pi. We know v equals r omega, so therefore it's 0.5 times by 40 pi, which is 20 pi, which is 62.83 meters per second. Now, since the plane's moving forwards as the propeller is rotating, the two velocities, the horizontal and the vertical, are at right angles to each other. Okay, so therefore we combine using the Pythagorean theorem to find the resultant velocity. So therefore it's going to be r squared equals to 62.83 squared plus 70 squared, all square root is 94 meters per second. We then know F equals mv squared over r, so therefore we can pop all the values in and we get 1.58 newtons. What's this force? It's the resultant centripetal force towards the centre, okay, of there, so therefore the centripetal force, okay, is the gravitational force in this particular instance. So I hope you've enjoyed this particular revision session. If you've been successful and learned in today's lesson, you should be able to answer A-level physics examination style questions, assess your understanding on A-level physics, and understand what topics you need to improve upon for A-level physics in circular motion. So thank you so much for carrying out this revision session on circular motion for AQA A-level physics. Thank you so much and have a lovely day.